In the previous class, we have seen estimation of population parameter with the help of maximum likelihood principle. In this class, we will take some two examples. One is to estimate the population parameter of normal distribution. Second one is to estimate the population parameter of a regression equation. At the end, we will have a demo by using Python. So, what is the agenda for this class is Python demo of estimation of population parameter for regression equation. Let us take one example. ID is 1, 2, 3, 4. Example 1 is estimation of population parameter of a normal distribution. Let us explain basic idea of maximum likelihood estimation using a simple problem. Let us make assumption that variable x follows normal distribution. The value of variable is 1, 4, 5, 6, 9. The density function of normal distribution with the mean mu and variance sigma square is given by 1 divided by root of 2 pi sigma square e to the power minus x minus mu whole square divided by 2 sigma square for the value of minus, the range of x is between minus infinity to plus infinity. So, in these equations we are going to substitute these x values, when we are going to multiply that, then we are going to take log of that, then we have to partially differentiate with respect to x and mu and equate it to 0, then we will get the population parameter. Suppose the data is plotted on a horizontal line this way. Think which distribution, either A or B, is more likely to have generated the data. Pause the video, you can think. The answer to the question is A, because the data are clustered around the center of the distribution A, but not around the center of distribution B. This example illustrates that by looking at the data, it is possible to find the distribution that is most likely to have generated the data. Now, I will explain exactly how to find the distribution in practice. Maximum likelihood estimate starts with computing the likelihood contribution of each observation. The likelihood contribution is the height of the density function. I will show you in the next slide. We use Li to denote the likelihood contribution of ith observation. Look at this picture. The observation 1 has contributed up to this much height. The likelihood contribution of first observation is this much. The likelihood contribution of second observation is this much. Similarly for third, fourth and fifth. For example, this is the first one. It is because there is x, we have instead of x we have substituted 1. For second data set we have to, instead of x we have to substitute 4. For third 5, the next one 6th, next one 9. Then you multiply the likelihood contribution of all the observations. This is called likelihood function. We denote that by L. So, likelihood function is the product of Li. This notation means that you multiply from 1 to n. In our example n equal to 5. So, you have to multiply 5 times. So, that function, likelihood function, that is defined by with the help of mu and sigma, is the product of I equal to 1 to 5 Li, when you expand this one, L1 multiplied by L2 multiplied by L3 and L4 and L5. So, it has come from the normal distribution. We are assumed that it has come from normal distribution. We know that probability density function of normal distribution is 1 divided by root of 2 pi sigma square e to the power minus, for first data set it is 1 minus mu whole square divided by sigma square multiplication, 1 divided by root of 2 pi sigma square for second data set e to the power minus 4 minus mu whole square divided by sigma square up to all data set. The last data set will be e to the power minus 9 minus mu whole square divided by sigma square. So, the likelihood function depends on the value of mu and sigma square, because look at this. So, here the likelihood function is in terms of mu and sigma square. In the previous slide we have found the joint probability density function of, for different value of x we found the joint probability density function of normal distribution. So, what we have to do? We have to take the log of that function, that partially we have to differentiate with respect to mu and sigma, and equate it to 0, then you will get the population parameter, that is mu and sigma. So, the value of the mean mu and sigma that maximizes the likelihood function can be found with the help of Python. At the end of the class, I am going to show an example for regression equation. The values of mean, mu and sigma which are obtained this way are called maximum likelihood estimator of mean, mu and sigma. Most of the MLE cannot be solved by hand, that is a maximum likelihood estimate. Thus, you need to write a iterative procedure to solve with computer, that I will take one demo at the end of the class. Now, we will predict the parameter of a simple regression equation. When I am starting the regression, I have explained the parameter of regression equation was obtained by having this assumption called least square method, where the sum of the square of the error is minimized. So, model for the expectation, fixed part of the model. So, expected value of y is beta 0 plus beta 1 x. The residual is actual minus predicted value, yi minus expected value. The method of least square, what we have done, we have find the values of the parameter beta 0 and beta 1 that makes the sum of the squared residuals as small as possible. This method of least square is applicable only when the error term is normal, that is residuals are assumed to be drawn from a normal distribution. Whenever this assumption is getting violated, we cannot go for least square method, we should go for some other method, that is a maximum likelihood estimate. Because we know that the next class we are going to study about the logistic regression, error term will not follow normal distribution. So, the maximum likelihood estimate can be applied to models with any probability distribution, that was the advantage of this maximum likelihood method. Now, we will estimate the parameter of a regression equation. We are interested in estimating a model like this, where y equal to beta 0 plus beta 1 x1 plus u. This u is the error term, u is error term. Estimating such model can be done using maximum likelihood estimation. Suppose that we have the following data, where x is given independent variable, y is given dependent variable. We are interested in estimating the population parameter beta 0, beta 1. Let us make an assumption that the error term follows normal distribution with the mean 0 and variance sigma square. We know that what is the error? Error is actual minus predicted value. So, the actual value is y minus predicted value is beta 0 plus beta 1 x. This means that y minus beta 0 plus beta 1 x follows the normal distribution with the mean 0 and the variance sigma square. The likelihood contribution of each data point is the height of the density function at the data point where y equal to minus beta 0 minus beta 1 x, because nothing but we brought this minus inside. This was the example. When you look at this, for the first data set, it is a 2 minus beta 0, because 2, when you go for first data set, the y value is 2, x value is 1. So, it become 2 minus beta 0 minus beta 1. For second data set, y value is 6, 6 minus beta 0 minus x value is 4, 4 beta 1 and so on. So, this height, this height is the contribution of each observation. So, on the likelihood function. So, the likelihood contribution in this example of the second observation is given by, second observation is y value is 6, x value is 4. So, 1 divided by root of 2 pi sigma square e to the power minus 6 minus beta 0 minus 4 beta 1 square divided by 2 sigma square. So, that the density function u equal to, we can simplify this way. So, we will go to next one. For other data set, we have done in the previous slide only for the for these values. Now, we will expand that function for all the data set. So, the product should go to I to n, L1, L2, L3 up to L5. See, for first data set, this is 1 divided by root of 2 pi sigma square e to the power minus 2 minus beta 0 minus beta 1 whole square divided by sigma square. For second data set, the same thing, 6 minus 6 4. For third one is 7 5. For the fourth one is 9 6, for the fifth one is 59. So, this function is likelihood function. Generally what we have to do, we have to take the log of this, then we have to partially differentiate with respect to beta 0, beta 1 and sigma and equate it to 0, then you will get the estimation of beta 0, beta 1 and sigma. You choose the value of beta 0, beta 1 and sigma that maximize the likelihood function. So, what we are going to do? We are going to, for the same problem, with the help of Python, we are going to predict this beta 0, beta 1 and sigma with the help of data set which you have considered. We will switch to Python. Now, we will see the application of maximum likelihood estimation for a regression equation. Before that, I have explained various theories. Now, we will take one example. I will explain how to find out or how to estimate the parameter of a regression equation using the principle called maximum likelihood estimation. The file name is, I have taken as MLE. I was importing the necessary libraries, import numpy as NP. You see that this is a new one from scipy.optimize import minimize. I am going to import a function that will minimize a function. Import scipy.stat. So, I have imported the data. So, there are this is a y variable is a dependent variable, there is a 5 data set, there is a x is the independent variable. For this x and y, I have constructed a regression equation. What is it regression equation? You see that by using our least square method, I have constructed a regression equation. So, when I go for the least square method, the regression equation is y equal to 0 minus 0.282 plus 1.6176 x. I am explaining this portion to you, right. This estimation was, we know that this was the y intercept, this was B1. So, with the help of what we have done, we are going to predict beta 0 plus beta 1 for x1 coefficient. So, this is the actual value. This was the, we know that this sample beta 0 B0 can help to estimate the population beta 0. Similarly, the sample B1 can be used to estimate the beta 1, that is for the population. So, this was the answer when we are using the least square method. You see the method is least square method. Now, we are going to use concept of maximum likelihood estimation, then we have to verify this answer whether we are going to get the same answer. This is the answer, we got the y intercept is minus 0.2882 and B1 x1 coefficient is 1.6176. The another parameter which is required for maximum likelihood estimate is, we have to predict the error of the standard deviation of the error variable, that is the our error term. So, for that you can type E equal to mod L2 dot residual. If you get E, this is the error term. So, we have to find the standard deviation of this error term, we got 0.06. This also we are going to predict. What we are going to predict? We are going to predict B0, B1 and this standard deviation of the error term using maximum likelihood estimation. This was the code for parameter estimation for regression equations with the help of maximum likelihood estimation. Import numpy as NP, from scipy.optimize import minimize, import matplotlib.pyplot as PLT. So, I am defining a function that is going to give you a likelihood function. So, LIK parameters, m is the slope, b is the y intercept, sigma is nothing but the standard deviation of the error term. So, for I in NP dot a range 0 to all the value of x, we are going to find out y expected value is nothing but mx plus b. Then this term is for estimating the log likelihood. So, this term is nothing but, when you go back previously, when you go back here, this is nothing but the whole equation, and we are going to predict. That is why I used for loop. So, for each I1, I2, I3, I4 up to I5 I will find out, then I will multiply it. That is why this has come, this one. So, this is nothing but what I have explained. Finally, the L will be returned. So, this is our x value, this x is taken from here 14569, this is nothing but this x value 14569, y value is 267915, 267915. So, like underscore model minimize, this is the function to minimize like dot np dot array. So, this is the randomly where I am guessing the answer. What this means, first one says the slope, second one says the y intercept, third one says the standard deviation of the error term. So, I am going to use this method called, there are different method, I will show you what are the different method for minimizing. L underscore b of gs underscore b, this is one method. When you run it, see this is the answer 1.61 minus this, what is this? This one is your slope, no this is not y, this is your x coefficient, this is your y intercept, this is the standard deviation of your error term. When you go back, we will verify this. See that the coefficient of x is 1.6176, we are also getting 1.6176. The y intercept is minus 0.288. So, here also getting y intercept, and the other thing we are getting the standard deviation of the error term is 0.604. So, here also see that this value also same. So, what a point we are learning here is the same problem can be done with the help of least square estimation method and maximum likelihood method. In both the way you will get the same answer. Now, we will take another example. This example we have seen when I am teaching simple linear regression method, that you can recall that auto sales example. The an auto company periodically has a special week long sale. As a part of advertising campaign, runs one or more television commercials during the weekend preceding the sale. Data from the sample of 5 previous sales are shown in the next slides. So, what you have seen, the number of TV ads is taken as independent variable, number of cars sold is taken as dependent variable. So, for this data set, first we will do a regression model with the help of least square estimation. Second, we will do with the help of maximum likelihood estimation. We will compare the answer, both will be the same. So, first we will do least square method. So, I have imported the data, this was the TV ads and car sold. When I do, you see there is a wireless ordinary least square method, we are getting this is the answer. What is that this answer? Y equal to 10 plus 5 TV ads. Here we can say x1 is a TV ads. Okay. Now, for this term we will find out what is the error term. See for finding the error term, say the B0 is 10, B1 is 5. To find the error term, I am going to save in the object called E equal to mod L2 dot residual E. So, this was the error term. So, if I find the standard deviation of this error term, we are getting 1.67. So, we are going to predict this standard deviation of the error term and your y intercept and the coefficient of x with the help of maximum likelihood estimation. So, there also you will get the same answer. What you have done? The same thing. Because already I have defined the a function, it will be easy for me just to replace the various parameters. In 0th index is m, 1 is b, 2 is sigma. So, this is our likelihood function. So, this is my x value, this is my y value, this is the function to minimize. So, I will run this program after a few minutes. This is just I have taken the screenshot of the Python program for your explanation purpose. You see that the final value, you look at this, this is your slope is 5 because this one, second one is the y intercept is 10, see the standard deviation of the error term is 1.67. You see it is exactly what we have done using the least square method. Now, I will go to Python environment, I will run and will explain. And one more thing you have to remember, this I have this is my guessed value 222. So, in the while running this program, I am going to change these values, still I am going to get the same answer. This is why just I am guessing the value. You can give any value, at the end you will get the same answer. Now, we will go to the Python environment, we will do the program. I have explained how to use maximum likelihood estimation to predict the parameter of a regression equation. I have shown the screenshot of the program in my presentation. Now, we will using Python environment, we will run this code, I will explain how it is working. I have imported the necessary libraries, then I have stored my data in the file called MLE. So, I have displayed this data. This data says y is the dependent variable, x is independent variable. For this data set, we are going to construct a regression equation using least square method. This was the output of least square method regression model. Here the y intercept is minus 0.2882, the coefficient of x is 1.6176. So, how can we write the regression equation? Y equal to minus 0.2882 plus 1.6176x. Next one, this is y intercept, this is the coefficient of x1. Next, we are going to find out the error by using this command, that is .resid. For this error term, we have to find the standard deviation of the error term. The standard deviation of the error term is 0.60488. Now, there are three things which I have done. We have find the coefficient, y intercept and the error term. Now, by using the concept of maximum likelihood estimation, we will verify this answer whether we are getting same standard deviation of the error, same coefficient and same y intercept. I have defined a function, the function name is lik. So, I have called the slope and y intercept and sigma. I in np dot range 0 ln x, I have predicted what is the y expected value by substituting different x value mx plus b. So, this L is nothing but the likelihood function. This likelihood function, I have explained this formula in my presentation. So, I am going to run this for all value of x1, then I am going to return the value L. This function is going to return the value L. So, I am going to minimize the likelihood function because the error has to be minimized. So, this 2, 2, 2, these values randomly I am guessing what will be the parameter, that is m, b and the standard deviation of the error term. So, I am going to display this model. So, this model says that my slope is 1.617. You see that when you do the OLS method also, the slope is 1.6176. The constant is, see here constant is minus 0.288. In OLS method also, the constant is minus 0.2882. Next, we predicted the standard deviation of the error term, that is a 0.604. You look at here also, we got the standard deviation of the error term is 0.604. Now, what I am going to do, I am going to change this value. For example, 2, I am going to give 3. This I will give 4. Let us see what value we are going to get. Again, we are getting there is no change in the answer. So, this value, this np dot array, this is our guessing value for our parameter. So, at the end we are getting the same answer. This is our example number 1. Now, I will go to another example. This example, when I am explaining linear regression, I have solved this problem with the help of simple linear regression by using least square method. I will clear my output. Here also we are going to do the same thing what you have done for previous problem. We are going to predict the regression model using OLS, then we are going to check that answer with the help of our maximum likelihood estimation methods. So, I am importing the library, then I am calling the data, this is the data set. The DV add is the independent variable, car sold is dependent variable. Now, I am going to construct a regression equation by using OLS, ordinary least square method. This answer is the 10 is the constant, 5 is the coefficient of TV ads. So, we can write y equal to 10 plus 5 TV ads. Next, I am going to find out the error term. So, the error term is this error term. Now, I am going to find out the standard deviation of the error term. The standard deviation of the error term is 1.67. So, now these parameter which I got with the help of least square method, I am going to get the same answer with the help of maximum likelihood estimate. I am calling the same function. So, this what is more important here, this function is L equal to length x divided by 2, this star np dot log 2 star np dot pi, this I have explained in my slide. When there is a different normal distribution, if you want to find out the parameter of that, we have to use this formula that I have explained in my class. You can refer my previous slides there. This 2 comma 2 comma 2 is the guessing value. So, for example, I am going to 5, I am going to change this number to 5. Now, let us run it. You see that the 4.99, actually our answer is 5, we got 4.9 approximately correct. The y intercept is 10, here also we got y intercept is 10, and the standard deviation of the error term is 1.67. So, here also we are getting 1.67. So, this way we have verified with the help of this Python program that whatever answer which you get with the help of OLS is the same as maximum likelihood estimation, because this maximum likelihood estimation method for predicting the population parameter is so generic, and most of the software packages they follow this maximum likelihood estimate for predicting the population parameter. As I told you, there are different ways to minimize. Suppose if you want to check the different methods, simply minimize, you put this question mark, you will get different methods. One method is, see that Nelder and hyphen Mead, Powell CG, BFGS, Newton CG, L, there are different methods. So, what you can do here, there is a method, you can change some other value, then we will get the same answer. In this class, I have given you an example how to use maximum likelihood estimation method for predicting the population parameter of a regression equation. I have explained the theory, I have taken 2 examples for that. For the 2 example also, I have concluded that you can use OLS method, that is ordinary least square method, and maximum likelihood method. In both the way you will get the same answer. Then I have explained how to do the coding and how to run and get the answer using Python, because this class is base for the next class which I am going to take is a logistic regression. Because the logistic regression, the method which you are going to use to predict the population parameter is maximum likelihood estimation. The next class, by applying this principle of MLE, maximum likelihood estimation, we will use and estimate the population parameter of logistic regression. Thank you.